Let's do our best to cover all these three topics. So the first one is 10053, and 10053, that is on the SQL Tuning Workshop 1, that is chapter 9. So if I open those PowerPoints, I have this one, 09A, which is inside SQL Tuning Workshop 1 lectures. Is this one here, 09A, and on the labs instructions, we have 09B, which is this one here. I open those two, and then I move to labs, where actually I have the labs, which is this one here, labs. And on labs, I have the 09E10053. So for labs, I have a copy of that directory over here, 09E10053. So everything is open. I have SQL Plus on the same directory, so I am ready to go here. This one requires a couple of setups. At the beginning, it says setup 1 and 2. So I'm going to execute both. Here, I'm going to say setup 1. This one is going to remove any SQL plan baselines that I have on my system. And it's going to remove any SQL profile that I may have. I have nothing here. And it's going to reset system statistics. And I end up with those values. Again, if you want to see what is that is done, just open the script setup1.sql. And in setup1.sql, I do the delete of SQL plan management. I delete profiles. I set a couple of parameters to false just to make it clean, the 10053. It's not that we usually do this, it's just for this section, so we don't see guaranteed feedback. And we don't see a group by placement, this is a query transformation. I delete system stats. Now what you see here is basically how we compute system stats for this particular lab. We specify some values and we set up the system stats, so everybody will have the same values. Then we show the values and then we flush the share pool, and that's what I did here. That was the first setup. When I do the second setup, on my second setup, it's going to be asking for a user ID. Any user is fine, so it's going to create a user. I usually use my short username that I use within Oracle, which is Sierra. Well, it doesn't matter, you can use whatever user ID and password. And it's going to create some tables. It's first going to create a table T1 with 1 million rows, then table T2, table T3. Let me just show you the script. For this setup, it's going to create T1 has 1 million rows, and this is the table creation, gathers the stats, or it drops any extended stats I may have. Then it gathers table stats, and it says for all columns size 1, meaning no histograms. It shows the statistics, creates 3 indexes. It's showing me the data is skewed for those columns. Creates table 2 with 100,000 rows, which is 10 times smaller. Drops extended stats and creates some indexes. The data is skewed. And the same for table 3. Table 3 is a little bit smaller, has only 10,000 rows, and the data is also skewed. This is fabricated data, so just to show you, the 10053 with the same set of data. So that means if later on you do the same labs back home, you will get the same results. So the setup is completed, so I'm ready to go. One thing I also did here, I opened this, this is my trace directory. So if I come here and I say show parameters user DOM test, that is my trace directory. So I open here my trace directory, remove all the traces. So whatever I create is going to be here, so I can see that here. So I'm going to delete again whatever I have. So I just start with no traces. And I am ready to go. So who uses here 10053? Who has used 1053 before? One person, okay? Or some of you guys. Okay, perfect. So we have some experience here. I used to say that 10053 was as hard as reading Chinese, but then I started getting people that they knew Chinese. They said, well, Chinese is easy. So So I moved to Russian, and again, I got some people from Russia saying, no, I can read Russian. Then I had to find something that was hard to read. I don't think anybody here can speak this language, right? No, there are only like 100 people in the world that can speak this language. So that's why I say, well, it's more like Piranya or Piraha. So I'm going to talk about some concepts, some sections of the 10053, and then some samples. I mean, how do we read the 10053? Well, first, what is this event 153? Is tracing the optimized series. During this class, tomorrow we're going to be talking about the 10046, which we trace the execution. The 10053 is the tracing or the parsing. So that means when the CBO decides to generate this plan A or this plan B or whatever plan, we can see those computations inside the 10053. In other words, if you ever want to understand the CBO, this is the file that you want to read because it spells out all the steps the cost-based optimizer is doing in order to produce an execution plan. The 10053 is quite cryptic, but it is very useful. It's just a matter of understanding, learning how to read this file. On 11G, as we have more query transformations, anybody knows what is a query transformation? Yes? No? Kind of? A query transformation. What is a query transformation? Go ahead.
It's like if you have an inline view and Oracle decides that it might be more beneficial to just create a direct view, or I mean a direct join.
Merge.
Merge it. Yeah. It changes a SQL statement to kind of more options.
Yes. Yes, the CBO has the freedom to rewrite your SQL on any way it wants, and there is only one commitment. It cannot change semantics, meaning the output should be the same. The output. But as long as it produces the same output, the CBO may decide to rewrite your SQL different ways. Why? Because by rewriting your SQL, it may find a better plan, better execution plan. So query transformations, they have been around for quite some time, but every release we have more query transformations. So when we're trying to understand a query transformation by reading the 10053, the more query transformations we have, the more complex it becomes. So that means if you open and see a 10053 from Oracle 9, it's easy. From 10G, it's more difficult. From 11G, it's even more difficult to read the 10053. Why? Because of the query transformations. That file is not fully parsable, meaning creating a tool to read the 10053, digest the file, and provide some meaningful information is very hard. Why? The 10046 is parsable, 10053 is not. So it's very complex. It's doable, but it's extremely complex. So when we look at the 10053, everybody has a different style. What I do, I usually look first for the plan table. Meaning, I usually look first, what is my execution plan, so I can see the execution plan. And after that, I may do a sanity check on CBO parameters. Then I move to single table section. And after that, I may look at the execution plan that has the lowest cost, meaning that is the one that the CBO decided to use. And if I was expecting a different plan, then I look for that different plan in the 10053 and review both. I compare the one with the lowest cost, which is the winner, and the one that I was expecting to win, which of course it didn't win because it has a higher cost. Okay? How do we do that? How do we do all that? First, when we look at the file, we will find a section that says SQL text, where we find our SQL. That is easy. I mean, just finding the SQL, not a problem. There is a section that has many abbreviations. This one is something you want to read at least one time. After you read it one time, in your mind, you kind of recognize some of these acronyms. Now, on the trace file, when you see SPJ, well, you know what it means. Let's say, when you see complex view merging, you already know what it means. So some of these, I mean, you get to memorize over time, and then when you're reading the file, it makes life easier. So at least at some point, you have to really try to memorize as many as you can, and then when you read the file, it's faster. CBO parameters. There is this section that says which parameters we're using from the optimizer. I only read this part, the ones with altered values, meaning the ones with non-default values. The ones with default values, I don't care. I care about this. The ones that they have no default values. Look at this one here. Remember these two? I changed these two on my alter session on the setup. They show on the 10053 that they were changed. Okay, bug fix control. Have you seen this before? Do you know what it means? What does it mean? What is this part for? This one here is a bug number. This one is something new that we have from 10G on. Where basically, from 10, it came like on 10.2 something, like 10.202, something like that. Whenever we have a fix, now from that release on, if the fix is affecting the optimizer, we can disable the fix if we want. Most of these are enabled by default. Some of these, they may be disabled by default. So that means the fix came, but it's disabled. Okay? So in those cases, it will show as disabled. In some cases, it will show like this. This one says, okay, right now it's disabled, but this is not the default value. So that means someone disabled this fix. Is that clear? So we can see that on the 10053. Regarding query transformations, they look like this. This is just an example. It says, okay, we're considering a query transformation for this query block. And then it's telling you the acronym here is telling you the name of the query transformation. And it explains what it is that it's doing. Some transformations, they are very well documented, so they explain step by step. Some of them are pretty cryptic. So there is no clear standard how the query transformations are documented on the 10053. Keep in mind the 10053 is created by the CBO development team, and they are thinking they are the only consumers of this file. So it's scripted, they can read it. But for us, it's like, okay, what does it mean? When I see, for example, CBQT, just to give you an example, what is the meaning of this? Exactly, cost-based query transformation, but it requires some knowledge of some of these acronyms. You say, for example, this one, joint factorization. Yes, some of these over time you get to learn. I mean, what is the meaning of each acronym? But this one, well, this one is easy because it says order by elimination, right? So some of them are quite easy, some others are not that easy to understand what they mean. One thing that is important is many of these transformations have this line here. It says final query after transformation. This is something new. We didn't have this before. In the past, in prior releases, there was a transformation and we were not able to see the SQL after the transformation. Now with 11G, we can see these with many transformations that actually it spells out what is the SQL text after the SQL was transformed. Is that clear? So you look for this keyword that says final query, for example, so you can see how the SQL was modified by the CBO. We have a query block signature. The query block signature, we take this SQL, for example, here, and it's going to show you what is the query block name. So every query block, anything that has select from where, that will be a query block. For an insert, that's a query block. Subquery is a query block. Everything that has a query block gets a name. And the name is used in all these hints, in all these steps, in the 10053. It's going to be referenced by the query block name. So when you look at the query block signature, you can basically map the different query blocks on your SQL. Yeah, go ahead.
So, in your slides and in a lot of other places, I see a lot of references to query transformations, but is there a good basic documentation or explanation of different types of query transformations anywhere?
Yes, I gave you that. Let me show you. I don't cover that in this class, but I cover the SQL Tuning Workshop 2, which I include all the material. So let me show you what is that. under the material here, if you go to SQL Tuning Workshop 2, under lectures, there is a chapter here with query transformations. This PowerPoint has 132 slides, and it goes through many of the query transformations. This chapter, it takes like over 1 day, one chapter, which is query transformation. It's very deep. Every time I teach that class, I get maybe like 10% of the people, they're extremely happy with the content, and 90% are totally sleeping in class. So, so it is heavy, but if you understand query transformations, you may come here and you may find many of the transformations. And in addition to that, there is a couple of references also that I include here, where it says for the SQL Tuning Workshop 2, on the references, there are a couple that refer to transformations. I have this one, cost-based query transformations in Oracle. This one is coming from development. And I have another one that says enhanced sub-query optimizations in Oracle. A couple of documents from development.
Thank you.
No problem. So going back to this one. Yeah, you will only find a few documents about query transformations, because that is kind of the core from Oracle. From the optimizer, you have two areas, costing and query transformations. And there is little information out there because that is considered kind of proprietary. But once you start working with the transformations and you discover how they work and how they look, it's like if you do that and you put it on a PowerPoint, that's perfectly fine. One thing I cannot do, I cannot look at the source code and publish what I see. But I have a rule, I never look at the source code. The reason I don't look at the source code is because everything I publish, everything I put on a PowerPoint is because I discovered the same way as any of you guys can discover. It's just a matter of finding how things work. Okay? So that is the reason why I can do this class here. I mean, a lot of people say, okay, you are doing an internal class. Well, it's not quite internal because everything that I put here, nothing comes from the source code directly. It's just how things work by reverse engineering things. Yeah, go ahead.
So the QB is the query block name.
The query block name.
And then entry rows and flag.
That I don't know. You know what they mean these two? I don't know what they mean these two. I don't use these two.
Number of tables in the front, too. And flags that really mean if these flags get updated as their transformation applied to it, since there is no transformation applied to this, or then it's 0. But if this block were like inside another one, and you will have a view merging, then it will have something and so forth. But those flags are not documented anyway. I mean, you have to look at the source code, and if you're determined enough, maybe you can figure out some of them. One more thing, these names are assigned initially by default whenever you have the first time in the query, and later as new transformations get applied, transformation usually what the idea is to rewrite the query in a different way. So the name of the changes, the name of the block changes, and that is assigned a very cryptic hexanumeric number.
Which you will see, one of the 10053, you will see this one is not a select 1, 2, and 3, but you will have a larger name. I didn't know what was this one here, but thank you very much. It also shows system statistics. You remember this from the prior PowerPoints, right? We have here the CPU speed, the single read time, the multi-block read time, multi-block read count. When we gather system statistics for Exadata, I understand this parameter changes, but I haven't played with it yet. So this is something, I mean, gathering system stats for Exadata, you should expect a change here. Then I mentioned table-based statistics. What you see here is like, okay, are basically a subset of the CBO statistics related to one table. Let's read it. It says for table T2, I have the alias is the same. So in other words, I'm putting no alias. This one is straightforward, the number of rows coming from the statistics, the number of rows, the average row length, the change count. This one that shows here is not gathered by DBMS stats. So if you see 0 here, it doesn't mean you have no change in rows. What it means is there is no information available because it's not gathered by DBMS stats. How do we get this to be populated? Analyze, which is not the same as DBMS stats. And we are saying, in general, we say, don't use analyze, use only DBMS stats. DBMS stats doesn't collect this one here, okay? So having a 0, it doesn't mean 0. It means we don't know the value. You want to add something there?
It's expected that in future versions, the DMS stats will collect information about the chain count. The optimizer does, in fact, in later versions, in 11.2, does in fact takes into consideration the chain count. But since there is no information, then simply that fix never gets applied to any. But yes, as it is now, the only way to get that chain count is by means of analyze.
Okay, thank you. Okay, so after we show the statistic for the table, it says, okay, on this table I have a reference to this column N2. This column N2 it happens to be the second column on the table, and I have an average row length of 3. The number of distinct values is 9. The number of nulls is 0. This density, what is this density? Well, if I have no histograms, this density is just 1 over this 9. That's what we have here. And then we have the minimum value and the maximum value. Fine. Then I notice that for this table T2, I have the following indexes. I have 1, 2, 3, 4 indexes. The first index contains only one column, which happens to be the first column on the table. The second index is the second column on the table. The third column, these 3 and these 3, they have nothing to do. In this case, they were the same number, but it could be totally different. This is the column ID that we have. And then what is everything that we have here? It says the levels on my index is 1. The height of my index is 1 plus whatever value we see here. So height and levels, they are correlated. We have the number of lead blocks, the number of distinct keys, the lead blocks per key, the data blocks per key, and the clustering factor. This is what we have here. Basic statistics. Then we have this section that says single table access path. Imagine our SQL has 2 tables. Well, this portion here is if I'm going to start the execution with this particular table, these are the numbers. So in this case, let's talk about table T1. If table T1 is the one leading the execution, I will have the following. This cardinality that you see here, that is the number of rows on the table according to the statistics. Then it says, if I apply whatever filter predicates I have, remember filter predicate is the one that says column equals value on your word clause. If I apply those filter predicates, my computed cardinality would be this number. Computed cardinality basically means how many rows I'm expecting to return from this SQL once I apply the filter predicates. That will be the value that you see here. And this one rounded is here. Then after that, it's going to say, okay, if I have these 1 million rows, and I'm going to select 90,000 rows, which options I have? There is one option that is always available, full table scan. I'm going to say, okay, if I were to do a full table scan, my cost would be $389. $389, basically what it means is I would expect this SQL to execute in the same time than 389 single block reads. That is what it means. You take the time of a single block read, which is normally like 12 milliseconds. Let's see in this case, what is the time for? Single read time, 12 milliseconds. You take 12 milliseconds, multiply by 389, the CBO is telling you that this SQL, if it is doing a full table scan, for T1, it will take about 389 times 2 milliseconds. Is that clear? Which is like what? Like maybe 4 seconds. So far so good? That is the meaning of cost. Cost is going to tell you 389 times single read time, and that is the approximate time the CBO is thinking this full table scan will take. Anyway, so we have this number. What is this number? This is response time. In this case, you will see the same value here, because this is assuming a file execution of 0, which means serial. If what we see here is for some degree, let's say degree of 2 or degree of 4 file execution, then we will have different numbers here. This is response. This number matches response, and this matches the cost of serial execution. Now, from this 389, about 375 are because of I/O. The remaining, the difference between these two, is CPU cost. So now with 10G and 11G, we have I/O cost and we have CPU cost. The biggest is I/O, like in this case. From 389, 375 is I/O. The difference between these two is CPU cost, which is this one here. This number is CPU cost, but not quite. The unit of measure is not the same unit of measure here. If we want to convert this one to the difference between these two, you know the difference between these two is like 14 something, right? If you want to compute that 14 something, you take this value, divide by 1000, divide by 12, and divide by 1500, and you get the 14. Okay? Anyway, it's not that you have to do it, but if you want to know, how do we translate this number to the gap between these two? That will be the formula. You want to say, where are you taking this formula from, right? Yeah, let me show you what it is, so you can have that later on.
If it's that relationship all the time, why even have that formula? It's different certain time.
Is different certain times?
Well, I guess the relationship, the cost and just times the I/O.
Yeah, with just knowing why different, you can get it, and that's it. That's it. Yeah, but if you have two different plants, they have almost the same cost, and the difference between the two, you can point to be CPU cost. You want to say, okay, why do I have these two different CPU costs? Where is this number coming from? So anyway, so in case you want to know, let me just show you what it is, so you may have that later. Yeah, on the material, if you go to SQL Tuning Workshop 1, on the references, I give you here the formula for selectivity and cardinality, and I also give you here the formula for costing. So for costing, that one I was just telling you should be, is this one here. You take the CPU cycles, divide by the speed, divide by 1000, divide by the single read time, and that's going to be your CPU cost. These CPU cycles that you see here is nothing but the large number that you see here. It's mislabeled. It says CPU cost here, actually it's CPU cycles. Okay? Anyway, too much detail here. Now it says, now if I were to read through this index I3 using equality predicate with a range, this would be my cost. So right now I have two options. I can do either a full table scan, and this is the cost, or I can do an index range scan, and this would be the cost. Which one is the lowest one? Full table scan. So that means if my SQL turns out to use this table T1 as the driving table, I will see a full table scan. Why? Because it's cheaper. Is that clear? Now, let's say I was expecting this one here. In that case, I would say, okay, I was expecting this one, it didn't win because it has a higher number. So I need to be able to decompose this and see where is it coming from and why this number is bigger than this number here. That's why I use the, by looking at the formulas again, I say, okay, in order to get to this value, I use this number, this number, this number, this number, and this one was incorrect. This one is too big, and it shouldn't be that big. Anyway, after we see all those single table access paths, we will see on the 10053 the permutations. Permutation is when it's saying, okay, if I have, let's say, two tables, which one I join first? I join A or I join B? I can go this way or I can go this way. If you have three tables, you have like 6 possible ways to join them. When you have 4 tables, you have like what, like 24, and so on. Is that clear? When it shows a nested loop is going to show like this. You're going to say, I'm going to try this nested loop join. My outer table, so that means on a nested loop I have the outer and the inner. The outer is the one that I read first. On the outer, if this is my cardinality and this is my cost, with bar execution of 1, which means serial, it's going to say, okay, the outer is easy because I do it one time, but the inner, I'm going to do the inner many times. How many times? As many times as this number here. So for the inner, it's going to show me on the prior pieces where I see the single table access path, I will see what is the cost for the inner one time. And then I multiply that by this number, and I end up having what will be my total cost for the nested loop. So the cost of my nested loop will include the cost of the outer one time, plus the cost of the inner as many times as cardinality of the outer. Is that clear? So I can review those numbers, and in this case it's saying, if I join T2 first and T1 second, when I join T1, my total cost, including this many times T1, is going to be this number. That is if I do a full table scan. If I use this index to do my join, this would be my cost. If I use this other index, this would be my cost. So now if I compare those costs, this one, this one, this one, which one is smaller of those 3 values? This one here seems to be right. We have to count. We have this number is smaller than this one and this one here. So in this case, if I go with an nested loop T2 to T1, this would be the best option, which is hard to understand because this one is a full table scan that I'm doing here. So it's saying, so far, if I do a nested loop, this would be my total cost, which is basically this one here. It's saying, so far, this is the best I can do. But keep in mind, this number represents how many single reads I'm expecting to do. If I multiply this by 12 milliseconds, this is a huge amount of time. But it keeps going. Then it's going to say, okay, let me evaluate a sort merge join. The same 2 tables. On the sort merge join, I have the outer table and I have the inner. So I take the cost of the outer, take the cost of the inner. We're talking 45 plus 389, plus the cost of the joint itself. And that cost of the joint itself adds up to this number. So if I take 1312 minus 389 minus 45, that is the cost of the actual joint. Now, if I compare this number to this number, it's clear that this number is better. So it's going to discard this. It's going to say, forget about the nested loop, it's way too expensive. I may go with a sort merge join. 1, 3, 1, 2. And then it's doing the same with a hash join. Saying, okay, I have 3 options. I do nested loop, I do a sort merge join, or I do a hash join. In this case, when it's doing the hash join, it's computing this cost, 945. 945 basically means 45 plus 389 plus the actual cost of the hash join, which is, this is the total. This will include these 2. And this one is better than this one here. So for this particular example, it's saying, you know what, the best option that I have is a hash join. So when it comes here and says best so far, it's going to show something like this. Now you recognize this value. 945 was here, right? Where is this one coming from? This 45. That 45 is coming from this one here, from the outer table. So I say, if I read the outer table, it's 45 by itself. When I join the next table, it goes up to 945, and this 945 includes this 45. So far, the best option that I have is to join T1 first, second T2, and a hash join between those two. That is what I see. At some point, I'm going to say number of permutations that I try. In this case, it only tried 2 permutations. Why? Because if I only have 2 tables, I can go this way or this way. I have only 2 options, 2 permutations. I already said that, but let's see you were paying attention. If I have 3 tables, how many permutations can I have? 6. Perfect. If I have 4 tables? 24. 5 tables?
120.
120. 10 tables? Many. A large number. Yes. And then at the end, I'm going to say, okay, my final cost is going to be 945. So you already tried this way. It already tried nested loop, sort merge join, and hash join for every permutation. And at the end, it's saying, from all the possible options that I have, I end up that the lowest cost is 945, and that 945 creates your execution plan. What do we see on the execution plan? As expected, we see the hash join, and we see T2 to T1, and we see the 945 over here. Now we do recognize these 2. Remember the 45, remember the 39? Single tables. So this 945 includes these 2. Any questions, please? Yeah.
I would say the bytes. What are the bytes? Say, and the time.
Okay.
2 bytes and time.
Bytes, it has to do with the size of the data that is being in. I mean, if you are reading one column, you're reading 1,000 columns from the same table, it's not the same, right? It's the amount of data that you are expecting to retrieve, which is projection. Whatever the data you are thinking, well, your SQL is projecting. I don't have a SQL here in front of me. Well, let's say we do select star. That means we have to project every column. So you have to take the number of rows. The number of rows is this one here, times the average column length of the columns that you are projecting. And that is the amount of data the SQL is expecting to process. This time is estimated time. How do we compute this? Well, take this value, 945 times 12 milliseconds. Why 12 milliseconds? Remember, the unit of measure of cost is single block reads. So multiply single block reads by the single read time, and you get this one here, which is estimated. It doesn't mean you run the SQL and it's going to take 12 seconds. This is estimated.
So it's not always true. Maybe it is.
No, keep in mind the CBO estimates. Of course, we want the CBO to be accurate, okay? But how accurate can we make it to be? Able here.
Just two comments. Yes, as Carlos was saying, it's estimated, and not every single thing can be actually estimated. One example is hierarchical queries. It's not possible to get an accurate cardinality estimation. So also without an accurate cardinality estimation, a lot of other costs kind of doesn't fit. Some transformations are also change the query in such a manner that you cannot cost the actual you cannot factor the whole cost of that transformation. So it still is heuristic. So there are things that you will not be able to estimate. Now, as Carlos was saying, I mean, you have those 2 permutations in the 10053, but in the what happens if you have 5 tables? How many think that the optimizer will do 120 permutations? Nobody? Okay, how many then? Anybody guessing?
There are max permutations 2,000 somewhere?
Well, yes, but I have only 5 tables, so I have 120 permutations. So how many think they're going to do the 120 permutations? Nobody? How many do you think it will do? Nobody want to guess? Well, then 120, because it basically is, I mean, the permutation says n factorial. So it's 5 times 4 times 3 times 2, that's 120 for 5 tables. So how many say all 120 will do?
Yeah, we have one answer.
Okay. So, but in reality, the optimizer doesn't do that. It remembers that some of those permutations are about the same no matter at what level do I do it. I mean, if I have 5 tables and I join first and second, the other 3 are going to be the same. If I reverse these 2, these 3 are going to be the same. And if I join these 3 in a certain way, if I change these 2, these 3 are going to be the same. So it remembers the ones that it did before, all the permutations it did before, remembers some of them, and just grabs and say, okay, I'm only going to change these 2 tables. So I don't see in the trace that it's going to cost again the first one, the second, the third one. It's not going to show. It only shows the very last 2 ones. So that can be a little bit of misleading in the 16053 when you start to look at it. You have to be kind of careful.
Thank you. Yeah, when the 10053 is finding, I already evaluated this branch. I already evaluated table 1, 2, and 3. It won't do it again. But it won't say that. So when you are reviewing the 10053, you notice there is like a hole. It says, okay, I'm missing this part. Well, that part, what it happened, it already did that a long time ago on the 5. But you need to be thinking, this part that is missing is because it already happened sometime in the past. So you have to find that part in the past. Meaning on the trace part, you have to look up and find the missing part. Is that clear? Yeah, because when it joins, let's say it joins table 1, table 2, table 3, table 4, table 5, right? When you are joining table 4 and 5, maybe there was a prior permutation where it was doing 1, 2, 3, 5, and 4. So that 1, 2, and 3 was already done some time back. So now when you are swapping to 4 and 5, you say, I won't do 1, 2, and 3 again. I already did that computation. So it's already in 5. But you have to find, when it's saying, oh, join order 325, now I'm joining 4 to 5. And you say, what happened with 1, 2, and 3? You have to look up in the 5 and find that 1, 2, and 3. In the same 5, yes. So it's there on the same 5. Right.
I have a question about the cost. In a situation where sometimes you have one query and more than one execution plan, I've seen in some cases where the cost, the plan with the higher cost is performing better than the one with the lower cost.
Yeah, it shouldn't be that way, but it happens. Basically what you are saying is the CBO is thinking this plan is better, but actually this other plan is performing better. So this is not normal. If you rely on that situation, it's not good in the long term, because you are relying on a mistake of the CBO. The CBO is making a mistake. Okay? So the point here is finding where the CBO is making the mistake. Why the CBO is thinking this plan is better when actually this one is better. It's not easy, but that is the root cause. You have to find why the CBO is thinking this plan is better when actually it is not. Okay? So that is kind of a red flag. When you see the execution plan has a higher cost and it performs better, that is okay. That's a concern. I mean, something that needs to be investigated. You want to add something?
Well, yes, and sometimes you have to also look into the context of the situation. When was that plan made? Because I can look at the EduNoir and look at a plan that the query had 1 month ago, and I have it now. And I can see, well, before it was a lot cheaper, and today it's a lot more expensive, something must be wrong in my database. Not necessarily. Maybe before you didn't have any statistics. So then the costs are, the cardinalities are only 1, the estimated costs are virtually nothing. So that's really not a problem. Now you have a more realistic calculation. And maybe it performs better because before you were having bad statistics and now you have better statistics. But when it's all part of the root cause analysis that Carlos is talking. But time is important. When you gather those statistics are important. What bind variables they were used on that other execution plan than this one? So there's a lot of factors that go into these calculations, and that's what Carlos is going to proceed with the rest of the presentation that goes into all these factors.
So to answer that question, when we have a situation, we need to review these numbers and see and find where the CBO is making a mistake. And the only way we can do that, we have to go back and recompute every step manually. Of course, if the execution plan is long, we just focus in those steps which contribute the largest to the cost. You see what I mean? Because if the execution plan is way too long, it's time consuming to recompute every step manually. We can do that, but it's very time consuming. So we just focus in those steps where the CBO made the mistake. Okay, also on the 10053, we will find this piece that says we have the other XML column. Have you guys seen this before? What is this?
Outline.
That is the outline. Yes, the outline of what? If you notice, if you read this, what do you see here? What is this? This one is basically telling you this one here. So this one here is the outline of the execution plan. Okay? We store that outline of the execution plan inside this column, all the XML, which is part of the plan table. So it is there. Notice this. What is this? What do you see here? A hint. So that means, can we take this hint? Use that. Okay, perfect. So you know the trick, right? But not everybody knows the trick. Can you explain what is the trick here? Can you explain to the group what is the trick?
Yeah, basically, when we have a similar problem, we find out that the good execution is behind the scene, and we took this trace file, we copy paste into the created outline, so whenever the same query hitting the table, hitting the database, is using this execution plan, don't worry about the stats at all. So we kind of like stabilize the entire execution plan.
You took this one and you created an outline with this manually, or you put this on the SQL?
We find a good access path in memory when we capture it, and through the trace, then we use this to attach to the outline. When we create an outline, when we create it and toggle the plan, we apply this one in. So when the query comes in, the same exactly query, everything, we're using this exactly hint to execute.
Is that clear for everybody here?
So the question is, if you use an outline, a profile, a baseline, what do
We
you
use an outline. We use profile. It's the same thing, statistical profile.
You can do this with a profile, you can do this with an outline.
The reason we choose outline because there is no license cost. The SQL profile I have using the whatever.
Perfect. Perfect. You are right. You are totally right.
Can you please explain one more time?
Hmm?
Can you please explain one more time?
Well, what we have here, as on this other XML, is basically this portion here is the outline of the execution plan. That is the execution plan. If you put this as a hint on your SQL statement, it gets to reproduce this plan here. Okay? Now, we cannot just go ahead and modify the application. In some cases we can, but in some cases we cannot. So if we cannot modify the application, but we know the execution plan, we can convert this into a stored outline or a SQL profile, right? Or a SQL profile requires a license of the tuning pack. So if we don't have a license of the tuning pack, we go with a stored outline. If we have a license for the tuning pack, we may go with a SQL profile.
Carlos, can you clarify the licensing issue? To use a profile, do I need a license? In other words, if I do not use the SQL tuning, can I still create my own profile?
The answer is no. Okay. SQL profiles, they require a license of the tuning pack. So you have to have a license for the tuning pack. It doesn't mean that you cannot do it on your derivative. You can do it, but you are out of license, and you don't want to be out of license. Okay, so whenever you are dealing with a SQL profile, it requires you to have a license of the tuning pack. Store lines, they require no license. SQL Plan Management requires no license. But SQL Profiles, they require license. Okay?
So in other words, even if I manually create my profile, I still need the license?
Yes. If you use the API DBMS SQL tool, which you require that to create it manually, it requires a license.
That's exactly the same as you can't query the workload tables unless you've got that license, right?
That is correct. That is correct. I mean, it's not like the data is not there. The data is there, but if you query the data, you are out of license, and you don't want to be out of license. Okay.
So outlines, are they still part of the future versions?
Well, the story says that they will be deprecated. I mean, we still support them, but at some point they will go away. So if you are on 11G, you want to use SQL Plan Management. Okay, you don't want to keep using store outlines. You're on 11G. Okay.
In case of 10G, I can use this one, GB version, and store it 11.4.
Well, on 10G, you can cut and paste this one and put it as a hint on your SQL. That requires no special licensing because it's a hint.
But still, it's mentioned GB version 11.2.4.
You mean this one here?
Yeah, this too. Do we need to change this one or we keep the same version?
You say for 10G or for what?
10G.
Well, 10G, I mean, I will put here the 10G, the 10G one. Yeah. Go ahead.
Is there a side effect if you continue to use the outlines?
Is there a side effect?
Yeah, is there anything wrong in 11G if you continue to use?
Not that, I mean, I don't see anything wrong, I mean, it would fail or anything like that, but it's much preferred to use the SQL Plan Management.
The problem with the outlines is, I mean, good and bad. You fix an execution plan, and yes, you fix it, but then you don't have the ability to have anything different. So if you have a one size fits all, is that something that your application can handle? Fine. If not, then you stop with it. You cannot have different execution plans for the same SQL. And sometimes you need to have. That is the problem. Now, whatever hint is not, like if you were just to copy this and put it in 10.2 just exactly as it is, just the one that says 11.2 is ignored. The rest is still applied.
Because these are hints, and remember with hints, I mean, it may ignore, if the hint is not valid, it will skip that hint.
The one problem that I've heard with this complete set of hints is that the query block name depends on the specific query. In other words, it's affected by the transformations that were used. So if at runtime a different set of transformations were used, then these query block names no
yes and no.
apply.
Yes and no. It's about the same comment that I made. That first, the cell 1, those are assigned automatically. As new transformations get done, the names of the blocks do change. But along with all the hints, there are hints that says I need to do this transformation on this particular block query. So they do mention I need to do a merge on this one. I need to do a joint predicate push in this other one. So it does mention. Now, even though that the hints are supposed to force it, there is not still a complete set of hints that will force absolutely every single execution plan available. There are still situations in which there's missing, or the hints are not explicit enough to do it. They still depend on the transformation taking care of or not to do it.
So basically what I was saying that what we have here is close to the execution plan, or not, it's not written on the stone. It doesn't mean that you put those hints and you will 100% sure you will get the same execution plan. Okay?
No, but what Abel mentioned was very valuable, because I can see now it says Are some query transformations mentioned in there?
Yeah, there are some query transformations here. This one is a query transformation. And it's disabled. In this particular case, it's disabled. But most probably here, if I remove that hint, I still get the same plan. Okay, let's move on. We are running out of time here, so I won't do the lab. The lab basically, I generate the 10053 and I show you what we have here. I navigate to the file. When we have histograms, the 10053 looks almost the same. What I start finding, it says histograms. I have a frequency histogram with 9 buckets, and I'm finding some values here. Everything else looks the same. But when I see the keyword histogram, I know I have a histogram for that particular column. So also in the computations, I may find some references to the histograms. I see that I have a popular bucket count. I have this one, bucket count. I have these two densities, old density and new density. Those are basically indications that I have a histogram from the 10053. In this particular case, when I create the histogram, the execution plan changed. Cost, it went down to 20. Remember what was the cost before? 900 something, right? In this case, the same data, the same everything. I create a histogram, and now I still have a hash join, but now I have index range scan in both tables. The cost is better. Does it mean this execution plan is going to perform better? Not necessarily. Most probably it will, but not necessarily. When I look at the other XML column, what do we notice here? This is the outline of the execution plan. Now we can see index range scan ascending on this query block, table 1. And you notice something here. When the index range scan, it doesn't mention the names of the indexes. What it mentions is the columns. Is that clear? So that means I may drop this index T1, I3, and create another index with a different name with the same columns, and it will be selected. Is that clear? It's selected by the names of the columns, not by the name of the index. But again, I get here my execution plan. Do you see any indication here that says histograms? No, it doesn't say anything about histograms. Why? Because it doesn't matter, it doesn't care. Histograms were used to produce the execution plan, but once you have the execution plan, it has no indication here that this execution plan was created with histograms or no histograms. It doesn't matter. Okay? If I use dynamic sampling, when I look at the 10053, I will see some marks about dynamic sampling. I can see dynamic sampling happening, and this piece here is important because if my SQL is taking a long time to parse, and I see dynamic sampling, I may suspect of the SQL that produces the dynamic sampling. So by looking at the timestamp, like in this case, I see the timestamp, I may see another timestamp after the dynamic sampling SQL, then I should be able to see how much time we're spending doing the dynamic sampling. Is that clear? Just keep that in mind. If you have a SQL that is taking a long time to parse and you are suspecting dynamic sampling, the 10053 can help you to identify those SQLs and how much time they are consuming. Dynamic sampling is going to give you a lot of details about how it's performed and the blocks that it's reading and how it prorates from those blocks. It's a lot of information, but it's there on the 10053. And it goes on, giving all those details. When I look at table access, table access, it also shows, okay, I'm using dynamic sampling. Dynamic sampling was actually used for this one. Anyway, a lot of details there. At the end, do you recognize this execution plan? Have you seen this before? Yeah, this is the same as we got from histogram. What is different is this cost. Okay, it's the same plan, it has a different cost. So that means the fact that you have two different plans computed by two different technologies, one was using histogram, the other was using dynamic sampling, they may end up having different costs. The cost is a little bit irrelevant. this plan is going to execute as good as the one from Histograms. It's the same plan. Is that clear? So the cost becomes a little bit irrelevant in this case. When I look at the other XML and I look at this part is identical. It doesn't matter if it was created by histograms, it was created by dynamic sampling. Here what we have is the execution plan. It doesn't matter what was the source. Okay? As mentioned before, this is the actual plan, what we have here. So we can basically use this one as hints on my SQL, and I can produce any plan that I want, with some caveats. It's not like a 100% proof, but it may get very close to the plan that I like. What happens when I have 3 tables? When I have 3 tables, then how many permutations should I have? On the 10053, I will find 6 permutations. Which is the optimal join order? Well, without knowing anything about the statistics, it's going to be very hard to say. But if I tell you all the statistics for all the columns, for all these tables, we should be able to compute what is the lowest cost, meaning what would be the best execution order. Is that clear? We have 6 possibilities. We should be able to compute this manually. It's time consuming. Yes, it is. But we should be able to do that. Some reference, I can only give you this paper from this gentleman that is old, but the paper is still valid. And I don't know for sure, why we don't have more papers, internal papers about the 10053. I don't even know if we are allowed to put this on a paper and say, okay, let's explain the internals of the 100. We're not allowed to do that? Okay. Yeah, because it's borderline. 10053 is basically explaining how the CBO works, and that is kind of a proprietary. So we as support, we cannot go in a lot of detail how things work internally, even if we knew how to do that, because we will be crossing the line of basically exposing what is proprietary.
Yeah, and also we have the situation that, and this is also true for every single trace that there is out there. Not only the 10053. It is a tool for development for debugging, it's not intended, never has been intended for users to consume. So they may decide on one version to change it to a completely different thing than the rest, than the other one. Tools that you build on top of it can break because you're trying to exploit the data of that trace. And we have people filing certain requests saying, hey, my tool now breaks because now they changed the trace to this. Well, sorry, they are entitled, development is entitled to change the traces whatever they want. So they add, remove, change, and modify the meaning of the traces as even between one patch set to another. So also keeping a documentation, all this, as Carlos says, it can be at some point viewed as proprietary. Like you were asking, what do those flags mean? Well, if I explain what those flags means, I may be breaching confidentiality of it. Some things we can make a deduction, like Carlos is doing. He deduced many of these values, and that's fine. He managed it, but others, we cannot make explicit mention of it.
Okay, so any question regarding 10053? No question. Okay, let's take a quick break. Can we make it like 5 minutes? 5-minute break? Yes? No?
Yeah.
Okay, let's do 5 minutes break so we move to the next section.
TK?
Alternate plan.
Can you vote for that?